Hey everybody, just wanted to welcome you back to part two of this great discussion on graphics that I had with my good friend Aaron Leese. Just a reminder, if you're finding these tutorials helpful, you may want to consider to support us on Patreon. Find us on patreon.com/The Audio Programmer. We have loads of rewards such as t-shirts, hoodies, and stickers to give away. And without further delay, here is part two.
You need to repaint. Right? So 20 times a second it goes through and it runs this paint routine. This paint routine does a few things here, but we'll skip those. Here's where it gets the data, right? P amp is just a pointer to my amplifier, pointer to the overdrive. And it says, look, if we have an overdrive plugin, then just we know what to do the get history routine, which is going to get us this array, right? And then what are we going to do with that data? That's the real question. Yep. So here we're getting the history array. Here we're going to create a path. We're going to resize it. We're going to do a not a number check. We'll talk about that. Rescale it so it's the appropriate size, and then handle fade, gradient, and rescaling. Now I'm going to go through quickly and just comment out everything that's fancy, and then we're going to bring them in one at a time and talk about them. So I'm going to quickly get this to a point where all we see is like, here's the wave. Just a simple drawing. So give me 1 second. Don't need a gradient. Oh, I thought you would like launch into re-saying all the stuff I said again.
Yeah.
Oh, you got dead air, dude. You can't do that.
I was actually just thinking that maybe we should save the gradient stuff we should do just a basic visualization for this tutorial and then do the gradient and start talking more about vector-based graphics for the next one.
Well, yeah, but I just assumed we would keep talking and you'll splice them.
Oh, I'll slice it up. Oh, yeah. Okay.
Do it in post, man. Do it in post, right?
Yeah, do it in post.
Don't need this.
Great.
History graphic. Yeah, and we have an image and a graphic, so we can talk about what the difference is, maybe.
Yeah. So just to talk a little bit more about what Aaron's done here. So he created a timer that is able to call a repaint function, and essentially what that does is that it gives you a rate at which you want to refresh what's happening on the screen. And what was so you were going at 20 milliseconds? Is that
20 times a second?
20 times a second. Yeah.
More like every 500 milliseconds.
Yeah, 500 milliseconds. So basically you have a couple different factors that you want to balance when you're thinking about drawing something to the screen. You know, you have your, okay, well, how many values, what's the resolution of the values that I want to take from my audio signal? Is it every 5th value? Is it every 10th value? Every 100th value? So that will give you a higher or lower resolution in terms of your audio, in terms of your actual UI display. Then you also have a factor which is, okay, well, how often do I want that to refresh? How often do I want to refresh the rate that I'm repainting that UI out? And so Aaron at the moment is doing twice every I lost it again. How often is it again that you're doing it? Every
50 milliseconds.
Every half second.
How often are we painting?
Yeah, no, painting.
20 times a second. So
20 times a second. Yeah, 20 times a second. Yeah, so he's repainting 20 times a second. So whether you want that to be higher or whether you want it to be lower, you can adjust that. So that's one of the things that Juce gives you is the ability to customize these different things. So great. So I did have a question, which was, if you go back to, why did you actually create another array where you're getting the history? Why not just get the history directly get values directly from your get history function from the processor?
Well, so we have an array. There we go. We have a bunch of values, right? But I need those values to be cool. Let me stop that. I need those values to be, I want them to be in a path, right? You don't have to do that. This ends up taking a little extra CPU time, but it's in the UI thread. So it's not a big deal that we're using a little CPU here. It's not like we're in the audio thread doing this. We're getting all this data, and then you want to take the data and put it into something that you can draw.
Yeah.
Right. So there's different ways to do that. So we could keep it as an array of floats and then just iterate through and like fill in points, right? And fill in the points in between them maybe. That sounds hard, right?
Yeah.
Getting to the image and like rescale each one and figure out which pixel to draw.
Yep.
An easier way to do that, and the approach that I usually use, is to say, we have this data, we want to take that data and we want to craft it into a path. Because the path is this great class in Juice that you can use to draw on top of a graphic. A path is just a set, it basically is an array. It's a set of numbers with just X, Y numbers that correspond to the pixels, X and Y grid pixels of the canvas, of the component, right? So the thing we do, let's take a look.
So what I hear you saying is that we could take individual values. We could take individual values from the actual history array that's happening in the processor and take those in real time and do it point by point. But that it would make your paint routine need to work harder, and it would have to repaint. It would have to repaint kind of on each point on the fly, rather than
I mean, kind of. It's just easier to put it in something that's friendly with the graphics classes, right?
Yeah.
So if you poke around the graphics, there's a lot of the sort of things that you'd expect with like basic geometry, right? You could have like a rectangle object, or you could have other types of objects, and there's paths, and a path is just a graph, is just a chart, right? Yeah. So when you have data that you want to draw on a component, it usually makes sense to put it into a path, because a path is the representation of that graph. The nice thing about that too is that you can then do a bunch of things to paths directly, right? Which include like scaling and transforms, but also include things like you can tell it to draw with the edges not being angular, so curve the edges, and it will automatically do this nice. If you rescale it, if we have it in a path, and we when we started this, we picked 400 pixels, 400 points in the array, but if all of a sudden let's say your plugin, your UI is resizable, and the user resizes it to be huge. Well, if you only had 400 points and it was doing this, you'd have a problem.
Yeah.
Or if you only have 400 points and you're filling in individual pixels, then you'd have holes in between them. But if you have a path, then Juice is really good about saying, okay, we have this path, we want to draw it on like this big space, so we do this, right? And making it pretty, making it work well for you.
Nice.
Yeah.
Great.
So let me do one thing. Where are we at? Scale to fit. Multiply all alphas. I think this will clear it. I could just do clear, huh? Okay, a couple of the other useful things that you need to be familiar with if you're doing this kind of programming in general, or it's for skeuomorphic for that matter too. Images and graphics are both classes in Juice. There's Juice image, Juice graphic. The image, you can think of the image as being the underlying data. Image is like, here's my pixels, here's my bitmap. And the graphic is a thin wrapper that allows you to draw onto the image. Okay. Right? So in our case, the way we're doing this one is we have an image, and we'll go over this in like a little more detail here as we start to dive into this. But we have an image, wrong one, in the UI, in our component right here. Oh, and we have the graphic. We could be redeclaring the graphic. This is a slightly better way to do it. We have an image, and then we're going to have a graphic, which kind of is the wrapper on that image to let us write on it. So in our paint routine, we're going to do things to that image. We're going to, in this case, we're going to get a path. We're going to put the path on the image, put the path on the graphic, I should say, draw on the graphic, which puts it on the image. And then we're going to take that image and we're going to just draw it on the component.
So would it be fair to say that the image is like a canvas?
Yeah, that is exactly fair to say. And the graphics are more like the tool set of like paintbrushes and things that you could apply to that canvas.
Okay.
So if you do like draw a rectangle, if I want to draw a rectangle, I do that in the graphic, right? But it ends up on the canvas. It ends up in the image. Yeah. Okay, so here we go. This is now the kind of simplest version of this. We're back to modulus every 20, so it's like a fairly responsive, quick waveform, and it's just a white waveform on a black canvas, and it's stretched out to fill the entire canvas, right? So let's go through. I've commented everything else out. We'll go through and look at each bit of code that got us to this point.
Yep.
And then we'll consider, what might we want to do to make this, what kind of bells and whistles can we add, right?
Yep.
Cool. Okay, so just going back to the code.
Yeah.
We just got our history right here. So we've got this array of floats. This is what we were just talking about. So put the floats into a path.
Yeah.
Since that makes it easier to draw. Right?
Yeah. So what we have in the history is going to be values roughly between -1 and 1. Even though if you have overdrive, it may go above or below above and below 1. So, but roughly between -1 and +1.
Yeah. In our case, we don't. I have a limiter on there to make that definitely keeps it between 1 and -1.
Yeah.
Well, and further, look at this. We're even doing it so this is from before I had the limiter. As we're going through, we're conditioning the data. As we're going through this, we are deciding where to put it on the path, and we might limit it. So if it's above 1, below -1, we say, it's too, we don't want that. Get rid of it, right? This is one way to do it. This is a little convoluted. This is just embarrassingly bad code, Josh, let me tell you. Because down here, we're going to rescale it. Scale to fit is this magical little thing. So it doesn't matter how big my path was. I could take the path and I could draw, go from 0, 0. I could draw this path that ends over here at like 2,000.
Yeah.
On the x-axis. And it wouldn't matter if I'm going to rescale it down here. But probably the first time when I first did this, I wasn't using rescale yet. So I was trying to figure out where should it be on the canvas, right? The canvas right now is resizable, but maybe it didn't used to be. Maybe it used to be 200 wide. So what I did was I went in and I said, well, what percentage across the history is this? I've got 400 points. If I'm at point number 200, it needs to be, that's halfway, 200 of 400. I need to be halfway across the canvas. So I was doing all this, fancy math to get it, or simple math really, to get it there.
Yeah. Yeah. So
but we're going to simplify now that we're, better at this stuff. I'm going to simplify, get rid of the scaled index.
Yeah.
Oh, it's not. Go ahead.
I was going to say another useful function for these types of things is the JMap function, which also takes the so if you have so in this instance, let's just say we have 400 values, as Aaron was saying, or paraphrasing what Aaron was saying. So our history at the moment is 400 values. So let's say that we had a 2,000 value x that the width of this rectangle was 2,000 values. Well, how are we going to get 400 values of history onto 2,000 values of X history? Well, what you have to do is you have to come up with some sort of scaling function that basically resizes or kind of interpolates to make sure that your history and your your screen width or your rectangle width are speaking kind of the same language. So that's how he's doing it. He was doing it with this scaled index. Another way you could do it is with this JMap function, which basically will take and magically kind of determine where each point needs to be drawn in order to make your drawing appear nicely on the screen. I hope I said that elegantly enough.
Yeah, it's so clear. Now, that can get messy. So again, now I've simplified it, right?
Yeah.
I'm going to say forget about X's and forget about my bounds for a minute. I'm just going to go through the history, right? I is now within the history. I've got 400 points, and I'm going to make a path that goes from 0 to 400, and it has the values, right? Then I'm going to take that path that goes 0 to 400 with values, and I'm going to stretch it so that it fits in the canvas, right? Which is what this scale to fit's going to do. Now, a couple things can go wrong, right? What if it's all zeros? If it's all zeros and I say, hey, stretch it out so it fits this and this, it can't possibly stretch it up enough because it's all zeros, right? And then you get a crash somewhere here in scale to fit. So another thing that could happen here, we've got these not a number checks. Going back to, I said this is an imperfect way to do it, having the array. When we're doing this array, if the last value in the array is being written, we have a problem with multi-threading because there's not a lock, and we don't want a lock because a lock would slow things down, and that's a problem. So it's possible that in this array, wherever it's writing, there's this not a number. There's this invalid number, right? In my case, what do we do if we have not a number? Well, we're just not going to draw it. We're just going to forget about it, right? That's one way to handle it. It's not the best, obviously. That's why we want to return to this stuff and fix some things. But for the person just starting out, try this, do it. You very seldom get not a number, and you can kind of work around it for prototyping. Yeah. And then later, when you're getting to the professional product, you want to kind of start tightening that stuff up. So dealing with the other thing, the stretching the bounds, we know now that it's going to go, since it goes, our X value essentially is going 0 to 400. We know it's going to go 0 to 400, but it might not go high enough so that we can stretch it without, getting into a divide by 0. The way we fix that is we make sure that we add a couple subpaths. So start new subpath essentially just starts a new path with a single point. In this case, we start one at 0, 1. We start one at 0, -1. That way, if the data is smaller than 0 to 1, it's going to be, it won't restretch it. It'll stay 0 to 1. The range will be 1 to -1. It'll stretch that out to be the height. We won't have any, math problems. Additionally, you kind of want the wave to be smaller when it's quieter and louder when it's bigger, right? So 1 and -1 are good axes to use there. If we thought this wave was going to go to +10 and -10, we might want to do something where when it jumps out of the bounds to +10 and -10, we're going to scrunch it down because we want it to display. We don't want it to paint off the canvas, right? So you can imagine some of these things like auto scale, so that if it's really quiet, you can see it. But if it's really loud, you can also see it, and it's kind of pushed it down. If you want to get really fancy, you can well, first of all, you can convert it to decibels instead of taking the raw data, which is a good thing to do. We could do that and see how the wave looks, and it looks a little different. If we're getting creative, you could also square the data, right? So that really small things get smaller, 1 stays at 1. You do a square root, which would stretch it a different way. That would then be an inaccurate representation of the waveform. But just be aware those sort of options are available to you. They're easy enough to do. So we could even do a couple if you want to see how they look. Okay, let's see if this worked. So we've simplified this, and then we'll make some other improvements in a second. Yeah. Oh, yeah, you see how it's
Yeah.
No, it's not. There we go. Cool. Yeah.
Yeah. And you see how it confines it to between -1 and +1 when you bring up the gain as well.
Yeah. So if I get, if it was now at tens, it would be scrunching it down.
Yeah.
It's not, because I have this limiter in, so it's actually chopping it, which is good because it's showing me that exact chop. Now, here's a problem, is that I don't really want it stretched all the way to the edge, right? So let's just, for fun, scale to fit 0, 0. Yeah, here we go. So this was all the way at the top, right? Scale to fit, this is XY width height. So I was telling it go from 0, 0, top left corner, and then make it full width, but only 80% of the height, which doesn't make a whole lot of sense here. Let's do 50% of the height. We'll start at we'll pretend we don't have any offset here, and I'll show you why this doesn't make sense. So this way, it's only going to be where? It's only going to be in the top half, because my height is half of the image, but I'm starting, whoops, I'm starting at the bottom. I probably can't see it. Yep, can't see it. It's down here. It's off the canvas, right?
Yeah.
If we do 0.1, and let's just so we really, so people get a quick sense of how this is working. Okay, not what we want.
Yeah.
Right. So what I'd like to do is have it at 0.1, but then the height is 0.8. So it goes from 0.1 times the height, so 10% of the way to 90% of the way. So there's a little bit of a buffer on the top and the bottom. I think that would look good. And then full width. While we're at it, let me show you another fun thing we can do. Again, to the image. So there's like one set of tools with the graphic, with the wrapper. And I had said, think of the other one as the canvas. But there is a set of tools with the canvas as well. And one of them is multiply all alphas, right? So this makes everything, I'll do 0.9. This is going to make everything 90% transparent. So what's that going to do? What do you think that's going to do?
I don't know, man.
I don't know, man.
What's an alpha?
Transparency. So images have red, green, blue channels, and then they have a transparency channel.
Okay.
Which tells it to render with some amount of transparency. In this case, remember, we're re-rendering on this thing over and over and over.
Faint, right?
Well, we're painting on it again and again. I don't clear it each time. So I have this image where I drew a waveform. Next time, 20 times every second, I'm going to draw another waveform. But before I draw the waveform, I'm going to make everything a little transparent.
Yeah.
And doing that, as you can see, now I just have a fade, right? So
That's pretty wild.
Yeah, you can see it kind of fading out. It is pretty wild. Now, it gets a little jumbled. So what if we also, kind of like Winamp style, we make it move a little bit, right? So that it gets out of the way and doesn't look as jumbled. Let's do that. This is another one of the tools that you have. Let's put a thing on it. This is another one of the tools you have in the image, not in the graphic, where we define width and height that we'd like to move from 0, 0 to get width to get height. So the whole thing, we're going to move the whole thing. And we have a movement X and a movement Y. Let's say we move it 0 on X, -10 on Y. So what's that going to do?
It's going to move it -10 every time it repaints.
what's this going to look like?
10 pixels to the left every time it repaints.
Whoa, there you go. Right?
Yeah.
And they're fading out the higher they get. In this case, they leave before they've faded very much.
Yeah.
So maybe we make it, instead of 0.9, we make this 0.4. What's going to happen? That should make it fade more quickly or less quickly?
Less quickly.
Less quickly.
I like how you're testing me here.
You got to keep it interesting. I like that you got birds outside your window.
Yeah. Yeah, better than my dog's barking.
Oh, and he lost. It fades more quickly.
Oh, does it? Oh, man.
Check it out.
Damn.
You notice my resize is a little bit wonky. Sometimes it's higher than it is other times.
Mm-hmm.
That's because of these. So maybe I screwed up. Maybe it's more than one. Maybe it's going up to 2. Maybe
So why do you start
in a larger range?
When you say start new subpath, I'm interpreting that as start a new line.
Yeah. So think of that as you're the artist. Here's the image, which is the canvas. This is this is a path. So right now it's abstract because we haven't drawn this path anywhere. We're just defining it, in our head. Start a new subpath is like you have a paintbrush, start a new line.
Yeah.
So I'm going to put a dot at 0, 10.
Yep.
And then I'm going to step back. Next thing I'm going to do is start another subpath. So put another dot at 0, -10.
Uh-huh.
Then I'm going to paint in everything else.
Uh-huh.
Right? So then I have this path, which at a minimum goes +10 to -10. And I already know it's going to go 0 to 400 because I'm adding 400 points, right?
So it's going +10 to -10, and then it's painting.
Yeah. So we can't see them because they're single points, but there's essentially a white dot right up here.
Yeah.
And right down here. So that when I stretch the thing out to fill this space, it fills the space with these 2 little dots. If those dots weren't there and I had a really tiny little waveform, it would make it big. I don't really want it to do that, right? I want it, if the waveform is bigger than +10, -10, I want it to tamp it down, but I don't want it to make it too big if it's really, really small.
I see.
There, this is what I wanted. So now if I really overdrive it, right, we have these big fat square waves. I've got a little bit of space on the top and the bottom.
Mm-hmm. Well, space on the top doesn't look like you got a lot of space on the bottom. Oh,
Well,
now it does.
Yeah, you can't see the bottom. We could draw a, here, let's do this. I think I was already starting to. Last thing I'm going to do. Well, let's have more fun. 0, 0 width, height. Okay, dissect these real quick. This is, again, G is the graphic.
Mm-hmm.
And I'm telling it, that's the wrapper on the image. And we're telling it, what color do I want to use? I want to use green. So I grab my green paintbrush and I draw a rectangle going from 0, 0 to full width, full height. And the line thickness is going to be 2.
Mm-hmm.
Right? That's what all those are. This should, there's no sub. This should put a green border around it. Yeah, there you go. So that's the canvas that we're working with. Okay, we're getting there.
Yeah.
Shall we do gradients and some color?
Yeah, let's do gradients and color.
All right. So we were just talking a second ago, right here, this set color green.
Mm-hmm.
This green.
Mm-hmm.
You can also do a gradient, right? So we're just going to do, here, let's get rid of this one. Not do that yet. I'm going to create a gradient. It's going to go from green to Give me a color. What do you like?
Red.
Green to red. Christmas. Okay, let's pull this up just so you can see it. The gradient when it's, yeah. Here's the constructor. It's, first color, second color, first color, position of the first color, second color, position of the first color, and then is it linear or is it radial, right? In our case, we're going from get width over 2, get height over 2, so the middle, to 0, get height over 2. So the edge in the middle of this rectangle. And it is radial, so it should be green in the middle and then changing red as we get towards the outside. And then I do set gradient fill. G is my main graphic.
So for people that don't know what a gradient is, gradient you could think of as kind of a interpolation between two colors. So you use it all the time. You see it all the time in web design. If you have like a screen and then it gradually kind of fades to black.
There you go.
That's what a gradient is. A slope. Yeah, a slope.
One of these are more creative there. That's what ours is going to be, green to red, we think.
Yeah.
Get that off my screen. Okay. There you go. Now, the middle's green, but we're not drawing anything in the middle. So since we have this box, it's going green, and when it's this far out, whatever that is, a third of the way between green and red is yellow, right?
Yeah.
Cool. So what if we take that same concept, we take a gradient. In fact, I'll even just take the same gradient and put it in up here, get rid of the white. So now, I guess we didn't really cover this. This is what here. So G is the graphic which was given to us by the component, right? That's how paint routines work. So G is our canvas. So it says, here's our canvas. What do we draw on this canvas? I'm going to take the image, the history image, which we just constructed. So we did that thing with the path and all that. Then we drew the path onto this history image, and then we drew the history image onto the graphic. The reason for this is because I want to keep a history of the thing so we can do the fade and all this stuff. It feels a little, feels like we're doing more work than we need to when you're thinking about, like, we have a image which has a graphic, and then we take that graphic and we write it onto another graphic, right? Don't worry about all that. This is first of all, we don't need to worry in the paint routines about optimizing as much because it's on the main thread. It's on the slow thread. Doing the drawing is not as big. Now, I should put some caveats. You got to be careful. If you do too much on there, you start slowing down the speed at which things draw. But for our purposes, this vector-based drawing is very fast. We have an image, we've drawn something on it, and we're going to take it and draw that onto the component itself. Then we keep the image. That's why next time when we draw it again, we can do like I said, do the fades, all these fun things. So this is that's the basic building block for how you want to think about, I need to draw something onto this graphic. There's two ways to do it. One is to draw directly on the component, which is what we're doing with the rectangle, for example. The rectangle doesn't change. And we don't need a history. It's not going to change. It's not going to morph. It doesn't need to know what it looked like a minute ago. Every time we do it, every time we draw the rectangle, it's going to be the same. So we can draw that directly on the component. Okay, let's take a look. Oh, something's messed. Oh yeah, I see it, but it's like black.
Oh yeah, I barely see it.
Oh, I know why. So we did set gradient fill on the component graphic, not on the history graphic. So now I set it on the history graphic, which is the history image, the thing that I'm drawing onto. And then we draw that image. So now it should be green and stuff. But probably my border isn't. Yeah, my border isn't. There you go. There you go.
Nice. It's Christmas.
Yeah. Green in the middle, red on the outside. And there is a fade there, but it's just disappearing quickly enough that you're not seeing it so much.
And stroke path is what's, just for people, stroke path is actually what's actually drawing the graphic itself. So you have your create subpaths, which are essentially giving you the lines, and that you're basically defining what image you want to construct. Then you have the color gradient, which is saying what color we want to make it, and then. But stroke path is actually where it actually draws.
That's it. So I just changed stroke path stroke type 3. 3 is just how wide. So now we have a much bigger, easier thing to look at.
Yeah, leave that there because it doesn't refresh as quickly on the. Oh yeah, that looks really good.
Yeah.
Nice.
Okay, let's do a few other fun things. I'm going to make this fade a little less quick, so we have more to look at. Move image section to a -10. Let's put one here too, just so we can see. Now, because we're redrawing this thing over and over and over, all of these can be dependent on fun little things like our maximum value. So here we are looking at our history, and you'll remember we didn't deal with anti-aliasing. We're only looking at every 20th sample. So the maximum might not actually be the maximum, but this isn't for scientific purposes. It's just for display. Whatever the maximum is in our current history, we're going to take that and just note it for a second. And I'm limiting it from 0 to 2. We should, yeah, maximum, it's already going to be a positive. Well, it could be a negative. Yeah. So 0 to 2, whatever the highest value is in that
array at that time.
Yeah. So let's do something color green. Let's play with our colors. Okay. We're going to change it to be rotated hue of max. Now, what do we think that's going to do? Come on, Josh, quiz.
Yeah. I'm trying to remember back to my university days, hue saturation brightness.
That's it. Yeah, these are fun concepts. We don't have to go into them too much, but essentially hue is the color wheel, right?
Yeah.
Yeah, so when you see these kinds of things, or this kind of thing, if you're moving the hue, you're going around the rainbow.
Yeah.
If I rotate the hue by 1, I go the whole way around the rainbow, and I'm back where I started. Right? Now we're currently taking whatever the max is, which is 0 to 2, and using that to rotate. So we could rotate as much as 2 times around the color, which we certainly don't need to do. Oh, but it is not. Something didn't work. Let's try a breakpoint. C grad C, that should be right. And our max is 2. Oh yeah, okay. I don't know why, maybe it's always 2 at the moment. Wait a minute. Let's do that. Okay. Get that off my screen. We also have things like, hue, saturation, brightness. We can change the saturation based on the maximum value. We could change it based on some slower RMS value if we wanted to. We could change it based on screen position, so that if you're dragging the window around the screen, up here it draws blue, but if you're down here it draws green.
Yeah.
Right? So there's really a lot of those kind of fun options you can start to play with. And we're just going to explore a couple of them. Oh, there you go. Hang on. Don't need to hear it. Whoa, look at it come alive.
Yeah.
So obviously I'm rotating. There you go. Rotating through the rainbow, right?
Yeah.
And a little quicker than I want to, really.
Mm-hmm.
And it maxes out. So I was wrong. I guess Juce doesn't let you can't shift by more than one. If you shift by one, if it goes more than one, it just gets limited to one. So yeah, the most I can do apparently. Although one should be back to green, so I don't know why it's stopping at pink, but you get the idea. So lots of different values can affect the color. Something similar is going on with this, right? I don't remember what exactly. We'd have to look at it, but the louder the incoming audio, the more the color shifts on this little thing.
Mm-hmm.
Yeah, there we go. And we got it fading out. What else didn't we cover, Josh?
So I think that's good for vector graphics.
Yeah.
Nice little introduction. That's a lot for me to work with.